the second part of the Arduino, which is like intermediate, in order to show you how the transition will be made from Tinkercad to Arduino as physical hardware. For those who were not with us yesterday, I'd like to remind you, you can hear me well. Can you confirm on the chat, please? My voice is clear? Great, okay. So, so for today, or for those who were present yesterday, I'd like to remind you that teaching Arduino nowadays is a must, and it's very important for the school, for you as teachers, and for the future of your students, since the Arduino will allow students to understand more the hardware, electronics, IoT, Internet of Things, how they will combine between input and output devices, since the microcontrollers, as you know, it's an electronic board that is available, or it is built in every component that we are using around us, from the washing machine, the fridge, the car, the elevator, the air condition, every single electronic device. This is what you should inform your students, that every single device, electronic device in our real life, it is controlled by a microcontroller. For schools, we have, let's say, the microbit for lower grades, from grade, let's say, from grade 3 till grade 6 or 7, and from grade 7 up till grade 12, we have the Arduino. And for those who are using our curriculum 01, which was updated last year, they can see clearly that starting from grade 7, we implement Arduino, or Tinkercad for Arduino, in order to make students understand the concept of microcontrollers. And when they will reach higher grades, in like grade 10, they will start by handling the hardware. I will share my screen for this today. Please tell me if you can see my screen, PowerPoint. All right, great. I remind you that by the end of this session, like we did yesterday, I will pick up an automatic draw online, and the winner will receive a full set of Arduino kit with board and sensor. And of course, I will be sharing with you the attendance sheet as Google form, in order to fill it and then to receive the certificate of participation, which I believe it's very important for you. So I'll try to go a little bit quickly, in order to, because I have 3 projects today I want to share with you, and I want to work with you. So I'd like to go quickly with what we did yesterday. Yesterday, we discovered, or we talked about the Arduino board, and we said that the pin 13, which is I'm encircling right now, it's the LED-in, built-in LED that is animated, and it's connected to pin 13. And yesterday also, we saw that by working on Tinkercad, by the way, I will be sharing this PowerPoint also with you by the end of this session, including amazing tutorials YouTube that we have created especially for our curriculum. So for the we saw yesterday that for Tinkercad, if we move the Arduino board, automatically we will have what we call the set built-in LED high and low with the wait seconds. Then we saw that if we implement a LED on the Arduino board, it will illuminate since the cathode it's connected to the ground and the anode is connected to pin 13. And then after, by clicking on the start simulation, you will see the LED blinking. And then if I move the anode from LED 13 to another LED like another pin like pin 10, I have to change the pin here in order to make the LED illuminate. And of course, I can click on the code and transform the block to C++ language. I will be showing you for the projects I have right now. And then I will be moving the code C++ to the Arduino board, and the project will be active. After that, we saw how we manipulate the digital pins by changing the address, and then how to make the same concept, but by applying two LEDs and one piezo in order to make them blink. And you will see easily that in the Arduino program, in the void setup, you have to declare, like you did for one LED, you have to copy paste in order to declare for pin 6, pin 9, and pin 13. And then after, you will be moving to making high and low for each LED. After that, or today, we will be discovering what is a serial monitor, which is very important. And this is this serial monitor will be really useful and helpful in terms of monitoring the data, since on the Arduino board we don't have, if you want, a screen to monitor the values read by the input devices or by any variables. So this is an example how we create a variable and how we make output on the screen the values, and how I can transform the coding blocks from Tinkercad in order to copy them into the C++ Arduino. Today, we are going to see how we will be creating a project with the push button. We will be showing also a project how to make a LED fading, and we will create a third project in order to see how we can use the LDR as input device in order to, let's say, control the LED while moving the light or approaching the light to the LDR. So I will not continue by this presentation in order to give time for showing you the project. This presentation I'll be sharing it with you, let's say, right now. So this is the PowerPoint. I'll be sending it on the is there any question? There is a sound, no? Okay, so this is the PowerPoint that you can download and that you can use in the classroom. It's really helpful for you while using the 01 book. So now I'll be moving to the Tinkercad, Okay, so I'll be moving to Tinkercad, and I'll be opening just to open my screen. All right. So the project that you can see on your screen, it's exactly the same that you can see here on my camera. It's exactly the same. And you as teacher, you have to believe that Tinkercad will facilitate a lot your task, since you will be building your sketch or your circuit on the screen. You will be building also the code, as you can see, by block, and automatically you will be converting the blocks into code in order to upload to the Arduino board in order to see the result. Before starting, I'll try to I'll be just 1 second. Just give me 1 second to open my my USB, because I have on it like 2 videos that I've done for you. So the desktop, Command V. Give me just 1 second. All right, it's done. So hopefully it will be working. Excuse me. All right, great. So the desktop. I will be opening a video that I have prepared for you. Please confirm me that you can see the video I'm sharing. I did not start the show, but can you confirm me on my screen that you can see the video? You cannot see the video. Okay, all right. Okay. So share screen, this one. Now you can see. Okay, great. So let me play the video. All right. Let me play the video. So here I built a push button, and I programmed my push button once it is pressed to illuminate the yellow LED. So look here how I have built my circuit. I'll be explaining it in a while, and then after that, how I built the block code, which is very simple, and I'll be showing you the detail of this program. Then after, I'll be playing a video on Tinkercad to show why once once I click on the push button, the LED is illuminating. So all this part is virtual on Tinkercad. And then after, I will be converting my block to C++. This is the code C++. And once I upload, I'll be watching the result or the detail, which is by pressing on the push button, the LED will be illuminating. So here, it's like an interactivity between, please just again, confirm me if you can see my Tinkercad, please. Okay, I have to share it again, maybe. Where I have to share. All right, share my screen. Okay, so can you see now my okay, can you see my Tinkercad? Okay, great. So I'll be starting step by step in order to show you how I will build my circuit by adding one LED and one push button. Yesterday we discovered that a LED is formed of two legs. The longer one is the shorter one is the cathode, and the longer one is the anode. And the cathode should be connected to the ground, and as you can see, the black cable is connected to this row, and in parallel this row is connected here to the ground. From the other side, I will be placing a 220 ohm resistor in order to protect my LED. And then after, from the other side, I'll be connecting my LED to digital pin 7. This is for the LED. For the push button, you have to place it or to insert it into the breadboard, as you can see on the screen. Two legs from the upper side of the internal section and two legs from the lower section. Here, from one side, as you can see, and it's clear, I will connect it to the digital pin 2. From the other side, from down, you have to connect one leg to 5 volt, and you have to put a resistor for 10 kilo ohm. Please here note that this resistor is 220 ohm. This resistor is 10 kilo ohm. I will be telling you why I'm using this resistor. And then after, from one side, I'll be connecting it to the ground. And from the other side, it will be connected to the terminal 1A from the other side of the push button. So this is how a push button is implemented in a Arduino circuit. It's made like this, and for the resistor, why we should put the resistor on this circuit, in order to make sure that once the push button is not pressed, this is the answer that you should give to your students. I mean, if the push button is not pressed, to guarantee or to make sure that there is no parasite or there is no signal that is passing from the push button to the Arduino board. Like this, my push button, my LED will be off. So I repeat, from one side, I built my LED by putting a 220 ohm. From one side, I place it to the digital pin 7. From the other side to the ground. For the push button, from the upper side, I connect it to the digital pin 2. From the lower side, I have to connect the two legs. One leg is connected to the 5 volt, and the other will be connected to the ground in order to cut any low current parasite. Okay, I will go to the code, and for the code, you will see that it's really simple. I have created a variable. I name it button state in order to tell me if the button is pressed or not. I will set my button state to read digital pin 2. Why 2? Because I connect my push button to the pin 2. And then I will build a condition, which is if the button state equal high, it means like if the button state is pressed or the push button is pressed, so set built-in high, the LED 13, and set pin 7 high, else I will off my LED. So if I click on start simulation and then I press on the push button, you can see that both the built-in LED on 13 and the LED on 7 will illuminate. So till now, this is how you should start your lesson in order to explore with your students. They can explore at home this experimentation. There is no risk for failure. Why there is no risk for failure? Because all is with simulation. So to move to the hardware, what I'll be doing, I'll be clicking on code. I will stop my simulation. I will be switching to block and text. I'll be selecting all the C++ code copy. I will be moving to just 1 second, to the Arduino program. And this is my push button program. I believe also you can see my program C++. You can confirm me on the screen if you can see. Okay. Mrs. Tahmiz asked me what we are calling is, please let me know. I did not get the question, excuse me. So this program in C++, it will initiate a variable button state to 0. And in the setup loop, I will be initializing the pin 2 as input for the push button, the LED built in as output, the button 12 or the digital pin 12 as output for the additional LED. And for the void loop, what I'll be doing, I'll be initializing the button state to read the digital pin 2, and there is a condition, the button state equal high, then the two LEDs will be high, and if the button state is released, so the two LEDs will off with a delay of 10 millisecond in order to guarantee this lapse of time, in order to make sure that the program is working well. So I'll go to tools, I click on port in order to make sure that the Arduino Uno is selected. I will, my board is connected. I will open my video. Okay, so as you can see now, just 1 second. All right, okay. So as you can see now, my project is real. So I will upload the program. You will see that the blinking is done, and done uploading. Once I press on my push button, hopefully you can see my LED. I will try to make the camera closer. So once I press on the push button, I believe now it's clear. So the LED is blinking. So by this example, make sure that you can control any kind of device with the push button. This is a simple project to show you how I controlled a LED, but with the push button, you can control a servo motor, you can control a pump, you can control any kind of Even you can control the 7-segment display that will be displaying on the screen numbers from 1, 2, 3, 4, 5, and up. So this is a basic manipulation, and really it's very important, since if you master this functioning as I showed you, so it will be ready to perform. Just one second, the chat. I don't know if I can upload with the chat an attachment. Just one second. Please, only the copy, the code from the Twinkle card. Yes, all you have to do, I will repeat it, please. I will repeat it. All you have to do is to open your code. I will repeat. Initially, it was like this. You built this code. So you go on code, you open the drop-down menu to select blocks and text, and then you select all the code, you copy, and you go to the, you go to, of course, Mrs. Sarah, I'll be sending you the recording. By the way, I forget to tell you that this morning, I sent the first recording by mail. So I don't know if you receive it. Did you receive by mail today morning? Okay, great. Okay, great. So I'll be sending also. Actually, I sent to all the mail I have. Hopefully that your mail is correct. In case you did not receive, please check in the junk mail, and if not, communicate with me via WhatsApp. I can send you the recording. Yes, check the spam also. Exactly. Okay. So and then when I copy the program, I have to copy to move to the Arduino. I will paste my program here, and as simple, the program will be uploaded. Here I have to remind you again and again that for students, they are not obliged to memorize the Arduino code. It's very important, okay? So they have to understand how to build the program, since the Arduino code is converted from blocks, and even if it's not converted from blocks, the students can go over the internet, and there is many examples for any kind of projects that you may ask. Okay, that's why I'll be insisting on the point that no need to share or to make students save or memorize how we write the code from scratch. Yeah, I mean from the first letter to the end of the program, they have to adapt in order to make the program function the way you want. So hopefully, okay, so in case you did not receive the recording, please, you can send me by WhatsApp, and I'll be sending you the recording. Look, I can send you right now the recording since you are here. Just give me 1 second. So that shareable link. Where is it? The chat. Okay, so here is, I'm sending to everyone. This is the link for the recording of yesterday. Okay, I'll close, and then I believe that for this project, it's okay. No, you are satisfied from the result regarding how to create a push button. I'm trying to see how I can send an attachment. Uh, just 1 second, your computer. I'll be sending you. Hopefully, I will. It's like, oof, it's like 51 megabytes. So I maybe I can share it with. Look, I'll try to see if I can. I'm sending you the push button program, the video. It's very important, and then I will be sending you the LDR program. So hopefully it will be sent. I don't know if you
عمتك غالية حكيتك بس عملت لك update.
Okay. So okay, good. I'll be closing. I'll be moving to the
لا فعادي حكي عادي كيف بيحكوا الواحد بده يزور ولا.
Okay. Now I'll be moving to the other program project, which is the LDR. Please, yesterday, if you remember, we talked a little bit about the LDR, which is a sensor, to read the light intensity in order to control the illumination of a LED. So please send it. I don't know if you received the videos or not, but I'll be sharing with you, since it's 55 megabyte. I'll be sending later on Dropbox, or I'll share it in a way. Don't worry. So here, it's my second project. I'll be showing you the LDR. This is the LDR. It's a small component that can read the light intensity. Okay, so I did a project. I'll be removing this one. It's okay, done with this one. You notice that today I'm well prepared, better than yesterday. All right, so start the video. I shouldn't. Just 1 second. Okay. Why it's not working? Just give me a second, because I moved my USB. So all right. So let me check how I can fix my problem in order to. Hopefully it will work, because it's very essential. Okay, good. So this project is made. You can see that the LED is illuminated. Okay, it's here. And the idea of the project is that when there is too much light, the LED will turn off. It's like on the what we call the street lights. So at night they will be illuminated automatically, and in the morning it will be. What time we finish the session? Yes, almost in like 20-25 minutes, maybe. I try to end it, hopefully. All right. So as you know, I for the LED, it's always the same. I've attached here two LEDs, one on the pin 11 and the other on pin 8. For the LDR, I attached a 10 kilo ohm resistor. From one side, I'll attach it to the 5 volt. From the other side of the LDR, I attach it to the ground. And from the other leg of the LDR, I attach it to the analog pin A0. What's the difference between analog pin and digital pin? It's very important to understand those two kind of pins, where analog pin can read different values of from the Arduino board. The digital pin can read just or high or low. So for sensors, usually, this is what you should inform your students, that for sensors, it's very important that to connect them to the analog pin. So the LDR could not be connected to the pin digital. It should be connected to the analog pin. Once I move to the code, you will see that the code is also very simple. I will print to the serial monitor. This is what I told you before, and I'll be showing you what is the serial monitor. So just 1 second. Okay. So just 1 second, please. Thank you very much. Okay. So for the code, I will insert a print to serial monitor. Look down where it is below the codes, the blocks. So once I run my program, I will click on serial monitor to see the values of reading. And then I will build a condition. If the read analog pin A0, why A0? Because I connect my LDR to the A0, is greater than 100, then I will turn my my LED connected on digital pin 11. Else, I will turn it off. So if I click on start simulation, I will click on start simulation, and I will click on the LDR in order to show the slider. I will open my serial monitor. Look here, the values shown on the serial monitor read by the LDR, 969 plus minus. If I slide to the right, so values are less than the beginning, and then when I move from a value higher than 120 to a value less than 100, you can see that the LED will turn off. What I'll do, I'll be stopping the simulation. I will go to the code. I can open here and switch block and text. I will copy the code. I will go to Arduino. Already I open, this is the LDR. I already pasted. So you can see that in the void setup loop, there is I initialize A0 as input, serial.begin 9600 as a configuration to communicate between the board and the computer, and the digital pin 11 in order to make the LED on and off. And in the void loop, I'll be showing the condition. I'll be reading the value of A0, and I'll be printing it on my screen. And if the analog read A0 is greater than 100, then I will illuminate the LED, and then else I will turn it off with a delay of 10 milliseconds. If I click on upload, I'll make sure that my Arduino is connected. If I click on upload, you can see that my program is uploading. I will click on the serial monitor. Look at the top right of the screen. There is a small loop. It's a serial monitor. So here you can see that the values read by the LDR are like 174. I will illuminate or turn on my my torch, for my cell, and I'll be approaching my torch LED light of the Arduino on the LDR, and the moment you see on the screen a value less than 100, you can see that I will make it clear, near please. Okay, look here, it's turned off, it's turned on, it's turned off, it's turned on. Depends from the values reading from the LDR. So on and off, on and off. So this is how I can control my LDR. Just give me, I will close the serial monitor. I will see how much pin in the LDR sensor. There is only 2 legs. Can the display be added on Arduino Uno to show the reading? You have, Mrs. Farhin, you can add a screen, but I believe it's really complicated and it's really hard for students to add a display screen. That's why we use too much the serial monitor. Just one question, can you confirm me, did you receive on the chat the 2 videos I've uploaded or not yet? Did you receive the 2 videos I've uploaded? Okay. So I'll be sending them because it's like 100 megas, so it will be complicated. I've deleted them and I'll be sending them later on. Now, in order to finish on time, I'll be moving to maybe I've prepared the LDR. Let me show you. Share screen. Where is my share screen? New share. So please confirm me if you can see my video, but it's not running. Can you see it? Okay. There is a question. All right. There is a question. What are these values on the monitor? Okay. I close the. Let me first run the video. It's really interesting and educational. This video. Once I click on the, you can see. So I'm approaching my mobile phone. So the LED will turn on and off. This is the circuit that we saw. This is the program on Tinkercad, and this is the program on C. And once uploaded, you can see the simulation on Tinkercad. And the real project that is done on the program, on the hardware, I mean. Okay, so I believe that those okay. So someone asked me, what are the values shown on the screen? Those values. So those values, as you can see, are I can make a delay of 100. Maybe it will be slower. Okay, if I open the serial monitor, those values are the light intensity read by the LDR, as simple. So if I approach my mobile phone by turning off the torch, you can see that the LED will turn off and on. I will approach my camera to the, so look here, once I approach my mobile phone, the value is now 62 and the LED turned off. When I make my phone away from my circuit, so the values read are 248 and the LED will be illuminating. So this is an automating system that is made in order to make students understand how input and output devices function in a clear way. How can the LDR connected to 5-volt and analog pin at the same time? It's a circuit, Mrs. Riham. It's a circuit that you should, from one leg connected to the to analog pin in order to read the values, and from the other side to power it for the 5-volt. Actually, I don't have enough background in electricity in order to explain more about how it is made. But if you go on Google, on YouTube, all the LDRs function in such in this way. So what you have to tell your students that actually they have to go to refer back to the science teacher or the connection of the LDR. Okay, I'll be explaining the connection of the LDR. As you can see here, the LDR has two legs, terminal 1 and terminal 2. For terminal 2, from one side, I will place a resistor of 10 kilo ohm. From the other side, I'll place it on the analog pin A0. And then from the other side of the resistor, I will connect it to the 5-volt in order to make sure that it will function correctly. And from the other side of the LDR, the terminal 1, it will be connected to the ground. This is how it should be. So I do have like 7 minutes. I'll not be making the fading effect projects in order to make sure that we respect the time. Maybe tomorrow we will allocate more time to make the servo motor, the ultrasonic sensor, and the fading effect. So I hope you enjoyed this webinar, and hopefully it was really useful. What I'll be sharing with you at the beginning is the attendance sheet in order to fill the form. To fill the form. Just 1 second. Where's my chat? Okay, so I'll be sending you first of all the attendance sheet. So please go on. I'll be all right. stop my sharing. All right. So please do fill the Google form for your attendance, and then I'll be sharing. Sorry. I'll be copying all the tutorials for those who were not yesterday present. Also, the video tutorial on the chat, also for everyone. Those YouTubes are really helpful, so you can keep them and work on them with your students in the classroom. And finally, I'll be playing a lottery game now in order to see who will be the winner for the Arduino kit for today. Before I'll make sure that please do fill the attendance sheet, because till now only like few people did fill it. I will give like 2 minutes before playing the so please do fill the Google form. Okay, and then now I'll be moving to share my screen again. Just tell me if you can see the spin wheel. Can you see the spin wheel, please? Okay, great. So the maximum number of the participants I sent today was like 320, I believe. I sent the codes, and I believe that you have on the WhatsApp. I sent you a code on the WhatsApp, and this code begins with NOV24-1 and the number. Okay, yes, exactly. So the number that you have on the WhatsApp, it begins with November 24, and after that you have the serial number. So what I'll be doing now, I'll be placing a spinning between 1 and 320. Okay, and the winner that he will see his number, he will open his mic or her mic, unmute all, allow participant unmute all, in order to congratulate him or her for this gift from our publishing house, 01 and right click. Okay, and here before I run my spin, okay, till now there is like 68 or 70 persons who filled the Google form, which is a good number. Thank you very much. So I'll be running the spin, and from now I can tell Mabruk and congratulations for the one who will be winning this full Arduino set kit. I'll be clicking. And the winner is 162. Is the number 162 present with us? If not, I will run it again.
Assalamu alaikum. I'm Shahid Hussain. My number is 162. Thank you very much. Thank you.
It's Shahid.
Yes, yes, yes.
Shahid Hussain. Congratulations, Shahid. From which school?
Thank you very much, Mr. Visham. Thank you. It's very informative. Thank you for this training.
From which school you are? Shahid, from which school you are? Shahid, can
International
you hear?
school.
Sorry?
Dome International School.
You are from Dome?